We learned that a sequence is just an ordered list of numbers. A series is where we're adding those numbers up, like here, for example. Notice my index, the j, starts at 3. So that means replace the j with 3, then add, replace the j with 4, then add, replace the j with 5, and we stop when we get to 6. So this series looks something like this written. All right, let's evaluate this one. So first of all, write out the terms of the series. So we would have, we're going to replace the I with a 1, x squared, x1 squared plus 2. And then replace the I with a 2, x2 squared plus 2. And then replace the I with a 3, x3 squared plus 2. Now, I can plug in these values for x1, 2, and 3. So I would have 2 squared plus 2, 4 squared plus 2, and 6 squared plus 2. So this would be 4 plus 2, which is 6. 16 plus 2 is 18. And 36 plus 2 is 38. So adding those up, we get 62, I believe. Now, if I have a constant being added repeatedly, I end up with just n times that constant. For example, if I have the sum from I equals 1 to 3 of 5, so I would replace I with 1, but there's no I, so it just stays 5. And then do it again with a 2, so it stays a 5 again. And then replace I with 3, and it stays a 5 again. And notice I have 3 copies of 5, so I'm just multiplying 5 times 3. That's what this is saying. A constant can also be taken out in front of the integral, out in front of the sum. So for example, let's say that I have the sum from I equals 1 to 3 of 5 times I squared. So then I would have 5 times 1 squared, 5 times 2 squared, and 5 times 3 squared when I substitute in I equals 1, 2, and then 3. Well, we know that we could factor out that common 5 and have 1 squared plus 2 squared plus 3 squared inside the parentheses, and these two are the same. So I could have brought the 5 out in front of the sum to begin with, and that's what this property is saying. If I'm adding two sums together, it doesn't matter whether I sum each first and then add it, or whether I add together the individual terms and then sum them, because we know that addition is commutative. It does not matter the order. Same with subtraction. The sum from I equals 1 to n of plain old I sums to n times n plus 1 over 2. Similarly, I have a formula for I squared and for I cubed. I'm not going to go through the derivation of these, but I'll just show you quickly why this one is true. So, for example, if I have I equals 1 to 3, say, of I, that would be 1 plus substitute a 2, substitute a 3, and we're done. So that's a total of 6 for that sum. But now notice that n in the expression is a 3. So using this formula, we'd have 3 times 3 plus 1 over 2. 3 times 4 over 2 is 12 over 2, which is 6. The same we got the other way. All right, so we're going to use these to evaluate expressions. Now, if I want to evaluate the sum from I equals 1 to 7 of I squared plus 1, let's back up a couple of slides. First thing that I'm going to do is I'm going to say I can break these into two separate sums. That's what this property says. So I would first write this as the sum from I equals 1 to 7 of I squared plus the sum from I equals 1 to 7 of 1. Now, the I squared, oops, go back. The I squared, I'm going to use this formula. And the 1, I'm going to use this formula. My C is a 1 and the N is the top there. So we would have, all right, so for the first formula, we have N, which is, by the way, the N's up here. So N, which is 7, times N plus 1, so 7 plus 1, times 2N plus 1, all divided by 6. That's plugging into the I squared formula with the n equals 7. Plus, the 1 is the constant times n, which is the 7 up here. Okay, so this is 7 times 8 times 14 plus 1 is 15, divided by 6 plus 7. Now, since this is a fraction, I could divide a 2 out of the 8 and leave a 4, and divide it out of here and leave a 3. I can also divide the 3 out of here and leave a 5, so it's gone from here, and there's a 1 in the bottom. So 20 times 7 would be 140 plus 7, so the total sum here is 147. All right, let's do this one. So I'm going to start by splitting it up just like I did that one. So I'm going to write this as the sum from I equals 1 to 12 of 5i plus sum from I equals 1 to 12 of 2. Now this one, I'm going to use this fact on that I can take the constant outside, and then we'll use this formula for the I. So I'm going to write this as 5 times the sum from I equals 1 to 12 of I, plus this guy is just like this one. So my constant is a 2, and the n in this case is a 12. All right, so this is 5 times. Now the sum of I is n times n plus 1 over 2. My n is 12. So 12 times 12 plus 1 all over 2 plus 2 times 12 is 24. All right, let's figure this out. This is 5 times 12 times 13 all over 2. So I'll cancel the 12 and the 2 and leave a 6. 5 times 6 is 30. 30 times 13 is 390 plus 24, I believe, if I've done my math correctly. So that should be 414.